methods of probabilities. How do we solve probability and what are the methods of probability? Okay, so first is a classical method. Now, this is the age-old method which we have been following. It's a very easy method to understand. So, in the classical method, if a random experiment results in n exhaustive cases, out of which m are favorable to the occurrence of an event A, then the probability of occurrence of A is denoted by P of A. Okay, so the probability of occurring of that event, the probability of occurring the heads when you toss a coin is the probability of that occurrence of the event. Now let's take for example, we are tossing a coin and we are expecting a head to come. Now the possibility of occurring of that head is event A. So what is the possibility of that occurring? There is only one possibility of getting head, that is when you toss a coin, it has to come, the result or outcome has to come as head, right? So that will be the P of A. And there is a formula directly to find out favorable number of cases to A divided by exhaustive number of cases. Nothing but exhaustive number is the sample space. All the possibility that you see is the exhaustive number of cases, and favorable number of cases is if I say if I want head, then how many heads do I get, or how many times when I toss the coin I get head, that has to be counted. Okay, that number will be m and exhaustive number will be n, or you can also write this like this: P of A is equal to n into A by n into S, which is nothing but m by n. So this is a classical method. This is the age-old method which we are following. Then apart from this, we have statistical or empirical probability. If an experiment is performed repeatedly under similar conditions, then the probability of the event of an event is a limiting value. So here what is going to happen is, if we are performing the event over and again, if we are performing the event over and again, then in that case you can check that that similar condition, if it is happening, then the probability of the event will become the ratio of m by n. Now this is a statistical way of solving the probability. Okay, just understand the concept. When we go to the problems, we will be using few methods of probability combined together. Okay, so that is what we will be doing it. Now here, limit factor, this limit has to be found out. There is a way of finding this limit for m divided by n. And this part is very important. This is where you will get all the problems from. So addition theorem. Addition theorem of probability for two non-mutually exclusive events. Non-mutually exclusive. See, mutually exclusive means if acceptance of one means rejection of other. When I toss a coin, if I get head, it means that I did not get tail. That is mutually exclusive. If one is taken, the other one is left out. So that is mutually exclusive. But when it comes to non-mutually exclusive, it means that there is a possibility of accepting both the events. Are you all able to understand? There is a possibility, there is respective possibility of either taking one of the event or either accepting both the events. So that is addition theorem for non-mutually exclusive events. Be very careful in first reading the question when it comes to mutually exclusive and non-mutually exclusive. So there is a statement which is given here. Let A and B be the two events with respective probabilities P of A and P of B. So the chance of selecting A will be P of A and the chance of selecting B will be P of B. So if A and B are two events where they are either selecting A or they are selecting B. Okay. then the probability of occurrence of at least one of those events or their union. So at least selecting one event A or selecting one event B or selecting the union of this. Now let us see the formula. P of A union B is equal to P of A. This is union. Union means both together. Okay. P of A, that is probability of A event plus probability of B event minus probability of A intersection B. Intersection means you have to find the common, but when it comes to union, we are going to combine both the events A and B. So that is one of the formula for the addition theorem. Another formula that we would like to understand here is P of A plus B. This also can be asked in the examination. So we will be doing the problems for this. So P of A plus B is equal to P of A plus P of B minus P of A into B. So here you have plus, but here you have multiplication. Okay, understood? Now this is a proof of getting the formula, getting the final formula. This we will see when we are solving the problems. If it's required, we will come back and understand this proof for the formula. Now, how did we get these formula is being explained here. So remember, addition theorem for non-mutually exclusive event is P of A union B is equal to P of A plus P of B minus P of A intersection B. And another formula for the addition theorem for non-mutually exclusive events is P of A plus B is equal to P of A plus P of B minus P of A into B. Okay, so this is the major two formulas that will be used in the addition theorem. Now moving further, we also have to understand the addition theorem for two mutually exclusive events. Now mutually exclusive events means if you accept one event, you will reject the other event. That is known as mutually exclusive events, right? So let A and B be two mutually exclusive events with respective probabilities. So again, we are taking two events A and B where both of them are mutually exclusive and their probabilities are probability of A and probability of B. Now, let us see how to find the probability for both of the events together. Now, then the probability of occurrence of at least one of these two events or union of events will be P of A union B is equal to P of A plus P of B. Now, if you see the difference between this method and the previous method, there is P of A intersection B in non-mutually exclusive, but in mutually exclusive, you just have P of A plus P of B. And P of A plus B is P of A plus P of B again. Okay. So when you accept one, you reject the other. So that is why there will not be any common thing between the event A as well as B. Okay. Did you all get a fair idea about the addition theorem? Fair idea has been understood? Now, in the playing cards, you will have four major types. Now, why are we understanding this? Because you will have problems relating to all of these playing cards. Okay. So, total number of cards will be 52. In these total number of cards, you will have two divisions. First is red card. Okay. And then there is another division which is called as black cards. So in red cards, all the symbols on the cards will be red in color. Okay. And all the symbols on the black card will be in the black color. Now in the red cards, you will have heart and diamond symbol. Okay. You would have seen this cards. I will show you, show the pictures later once we understand and learn here. Okay, you will have a heart card here and you will have a diamond card also. So this will be a diamond card. Okay, so this in red color cards, you will have heart cards, which will be 13 cards. Heart will have 13 heart cards will be there and 13 diamond cards will be available. Now the naming of the card, this is also important for you to remember because in the problems they will ask you all the combination of this. The naming of the card will be from A. A is nothing but ace. Ace means 1. Okay. A is ace. Ace is 1. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A and then 2, 3, 4, 5, 6, 7, 8, 9, 10 you will have. And instead of 11, 12, 13, you will have J, Q, K in every set of cards. Okay. You'll have J, Q, K in every set of cards. So this is how the numbering will be there for every set. First number will be A and then you'll have 2, 3, 4, 5, 6, 7, 8, 9, 10 and then the last three numbers will be J, Q, K, that is Joker, Queen and King. Okay, many of them would know about these cards, but then few of them who do not know, please listen and understand. Okay, now next is the black set. Now how we had hearts as 13 cards, similarly diamonds will also be 13. Okay, now next after that we have spade. Now spade, it will have a symbol something like this. Ulta heart will be there and then you will have a small stand for that. Okay, this is spade. This is the spade card and again for spade there will be 13 cards here which you will have the same numbering from A to 3 to 10 and JKQ. And finally you will have the clubs card. Now the clubs card will have something like a flower like this. And then you will have a stand like this. Okay, not very accurate, okay, but you will have a flower like this and that is called as clubs card. Now in the again clubs will be of 13 count. So 13 plus 13 plus 13 plus 13 will give you 52 cards. So in 52 cards there will be 13 plus 13, 26 red cards and 26 black cards. In 26 red cards you will have 13 hearts, 13 diamond and 13 spade and 13 club. Okay, so this is the sample space. These are the possible ways where the card can have the outcome. When you're playing cards, how the opposite person will make the move can be understood by this probability. So did you understand this part of the card explanation? Any doubts in here? Now the next concept is combination. We will be using this combination widely in the probability theory. Okay, please understand the concept of combination well. Now combination means a group or selection. Now we combine a top and a pant or a shirt and a pant and call it as a combination, right? So it's a group or it is a selection. Then the number of selections we do for our items where we take n items out of it. Now let's say there are 10 shirts and out of 10 shirts we are selecting 2 shirts. So out of 10 being the items, we are selecting 2. So then we are making a combination out of 10 we are making a combination of only 2. Okay, so that is NCR. we have, let's say, 20, what do you say, 20 jackets. Okay, 20 jackets. Out of 20 jackets, you are selecting 5 jackets. So 20C5. Okay, there is a formula to find the combination. The formula is very easy. What you have to remember here is n factorial divided by n minus r factorial into r factorial. Now n factorial is nothing but n into n minus 1 into n minus 2 and so on. So if you have 4 factorial, it is nothing but 4 factorial into 3, sorry, 4 into 3 into 2 into 1. Okay, if you have 10 factorial, 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. So from whichever number they have given, just subtract 1, 1, 1 until the last number 1 you have to take. So this is known as factorial. Okay, so n factorial, whatever number you get, that until 1 you have to calculate, and n minus r you will get a number, so that will become n minus r factorial and into r factorial. Understood combination? We have so much selection with us, we have so much of sample space. Out of that, we are selecting 2, we are selecting 5, 10, which how much ever we want. So that is a combination. Now, another important thing to note is NCR. See, these are few things you will have to just memorize this. NCR is equal to NCN minus R. NC0. Now, when I don't select anything from the list, the value will be 1. Okay, which is nothing but NCN. NCN is also 1. Then NC1 is equal to N, which is nothing but NCN minus 1. We will be using this in the problems and you will have to remember these things. So let us just see a problem of a combination for you to understand the concept better. A bag contains 3 white balls and 7 black balls. So a bag is having 3 white balls and 7 black balls. Okay, so what is the probability if 2 white balls are selected at random? Now that bag, it will not be arranged as 3 white balls and 7 black balls. It will all be mixed up. Now what is the possibility of me just when I pick 2 balls from the bag, what is the possibility of getting 2 white balls at a time? Okay, so that is the question. In such questions, we will be using the combination. Now, what is the total number of balls? We have 3 white balls plus 7 black balls. So, totally, we have 10 balls which is there in the bag. Correct? Now, out of total 10 balls, we are supposed to select 2 balls at random. Correct? Now, actually, how many white balls we have? We have 3 white balls. Okay. So, in that case, what we are going to do is 3 out of 3 balls, 3 white balls, I have to select 2. Correct? Out of 3 balls, I have to select 2 balls. So, I will find out 3C2. Now, what is the formula for the combination? Now, formula for the combination of 3C2 is n factorial. See, 3C2 is nothing but NCR. 3 is n, R is 2. So, n factorial, that is nothing but 3 factorial, divided by n minus r, 3 minus 2 factorial into r factorial, that is 2 factorial. This is the formula. Now 3 factorial means 3 into 2 into 1. Correct? Divided by 3 minus 2 is 1 factorial, and again 2 factorial is 2 into 1. Now 1 factorial is 1 only. You will not have anything more. So 2 and 2 I will cancel. 1 and 1 I will cancel. So what is the answer? 3 is the answer. Okay. So 3C2. For 3C2 the answer is 3. Did you all understand this part of finding the combination? Out of 3 white balls, I am selecting 2 white balls. Now how will I select that? There are 3 ways how I can select 2 white balls. Did you all understand this part? Okay. Now, listen here. A bag contains 3 white balls and 7 black balls. What is the probability if 2 white balls are selected at random? Now, randomly we are selecting. We are not selecting purposefully. So they're asking us the probability. Now, probability means we also have to find out the final answer. Correct? Now, what is the probability formula here? What is the probability formula? Favorable number of cases divided by exhaustive number of cases. What are the favorable number of cases? Out of 3, getting 2 is the favorable number of cases. And apart from that, what are the total cases? We had 10 balls in the bag, and out of that we are selecting 2 random balls, right? So that 2 random balls we are thinking, or we are saying that 2 random balls are white balls. Okay, so this formula is being used here. This formula is being used here. That is favorable number of cases. What are the favorable number of cases? Out of 3 balls, out of 3 white balls, we are considering 2 white balls. And what are the total number of cases? We had 10 balls in the bag. 3 plus 7, 10 balls were there in the bag. Out of that, I am selecting 2 balls. Understood? So this will be the probability of getting, or probability of selecting 2 white balls at a random. Did you understand this part? Now in 10C2, what we will be doing is, again, same formula you have to use, n factorial divided by n minus r factorial into r factorial. Okay, so that is the formula, and we have to solve it. Now 10 is n, r is 2. Okay, so 10 factorial divided by n minus r, that is 10 minus 2 factorial into 2 factorial. So 10 factorial means 10 into 9 into 8 factorial. I will stop until there. Why am I stopping until there? See the denominator. 10 minus 2 is 8 factorial, and then into 2 factorial. Now, in the numerator, I have 8 factorial, and in the denominator, I have 8 factorial. I am cancelling both of them so that factorial is taken over. It is not there. Okay. Next, what is left out? 10 into 9 divided by 2 factorial. So 2 factorial is 2 into 1. So 2 ones are 2 fives are, I can do 5 nines are 45. So we understood what is the value, of 3C2, and we also understood the value of 10C2. Now take both of the values. 3C2 value is 3 and 10C2 value is 45. So 3 by 45, the probability of getting 2 white balls randomly, when you pick 2 white balls randomly, it is 0.06667. Okay, this is how you find the combination of the problem. So first we will be applying the combination concept into the problem, and then we will be using the probability formula to find the the result of the probability. Understood? Did you all understand? Okay. Now, the next, see, these are important things you have to know before solving the problem. Now, one more thing. Sample space in a random experiment of rolling 2 dice. Now, let's say we are playing Ludo. Now, in playing Ludo, we are playing with 2 dice, or 2 of them are playing the Ludo separately, if you think like that. So, what are the possible outcomes that you can get? Okay, so that is easily represented here. What are the possible outcomes when you roll 2 dice? Now dice will have the numbers from 1 to 6, correct? From 1 to 6, 1, 2, 3, 4, 5, 6. So when we are rolling 2 dice, you have 1 dice numbers given here, that is 1, 2, 3, 4, 5, 6. Another dice which numbers are given here, which is 1, 2, 3, 4, 5, 6. Okay. Now what are the possible outcomes we can get? So you can get 1 and 1. When both the dice is rolled at a time, you can get 1 and 1 on both the dice. Like how you have the Jumanji dice and all, no? And every time they roll the dice, the scenario will change, or they'll be in a different world. So here 1 and 1 can be the result. One dice can be 1, the other dice can get 2. See, 1 and 2. 1 and 3. It is easy to remember like this. Okay, 1 and 4, 1 and 5, 1 and 6. These are the possible outcomes that can come by rolling the dice many number of times. Okay, but here we are rolling the dice how many times? 2 times. So again, next time, this dice number 1 can get 2, but dice number 2 can be 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Okay. Similarly, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. And 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. So one dice can give you 5, other dice can also give you 5 as the number. One dice can give you 6, other dice can give you 5 as the number. So like this, these are the possibilities whenever you roll 2 dice together. So what is the total possibilities? What is the total possibilities? 6 to the power n. So we are rolling the dice 6 times. So 6, sorry, we have 2 dice which has been rolled 6 times. So what will be the total? 36 will be the exhaustive outcomes. So even if you count here 1, 2, 3, 4, 5, 6, 6 like this and 6 like this is 36. So you will get overall 36 outcomes when you roll 2 dice. Okay, so the total number of exhaustive outcomes are 36. Understood this part? Any doubts until here? Okay. So we shall stop here for today. Tomorrow's class will start with the problems. Okay. I will send this notes. Please go through it once again. If you have any doubt, we shall discuss in the tomorrow's class to understand. Fine.